All right, so basically, here's the whole periodic table. You've got one little tower up there, you got this tower, you got the valley, and then you got these two towers here. Yes?
Yes.
Okay. Now, first of all, these two over here. All right, what almost always is the charge of this one? Plus 1, or 1 plus. We'll learn why we do it differently later, but that's 1 plus. And these are 2 plus, yes?
Yeah.
Okay, if you come over here, this is a ridiculous oversimplification, but when they are ions, what's the charge of the next column? 3 plus. Okay, I got one too few columns. There we go. All right, now, what's the charge of the very last column? What do they do?
They're noble gases.
They're noble gases. They do nothing. Don't take them to parties. They're boring. All right? What's the next column?
Minus 1.
1 minus. Next column?
2 minus.
2 minus. Let me guess.
3 minus.
3 minus. And these guys?
4 plus or
Plus or minus 4. All right? All right. Now the naming systems. 3 basic naming systems. The first one is when you have something over here with something over here. All right? Simple ionic naming. All right. So for instance, if sodium, which is about there, combines with chlorine, which is about there, the only possible name is sodium chloride. Right? And the reason is there's only one way that a sodium hooks up to a chlorine, and that's 1-to-1. All right? There's only one name for this. If magnesium hooks up with chloride, it's simply magnesium chloride. You guys wrote formulas last year, yes?
Mm-hmm.
Okay, so that should be no problem. All right, the name for this is simply magnesium chloride. Good so far. So that's the first one, simple ionic bonds. All right, next one. If we talk about this valley here, all right, that is the Valley of Strange and Wonderful Things. That's the official name. All right, the Valley of Strange and Wonderful Things. Why? Because they get a whole bunch of different charges. Okay? Later what you'll learn is that it's because of the D shells and so forth and so on. But for right now, they get a whole bunch of different charges. So when they bond with something over here and make an ionic bond, we have to have a different naming system. Because we could have, let's just pick one, iron. Iron could bond with chloride, and we could get FeCl2, and we can get FeCl3. Okay? And we have to distinguish between those. These are both what? Iron chloride, yes? So how do we distinguish between them? Anybody? Roman numerals. So this one would be iron 2, and this one would be iron 3. Is this familiar?
Yeah.
Okay. So that's the second bit. The third bit is when two things in this tower combine with each other. In other words, we make some form of covalent bond. Yes. Background music appreciated. All right. Now, different naming system. If we hook two molecules over here, for instance, we make NO, NO2, N2O, N2O5. They all exist. All right? Now, instead of giving the number of the charge, because they're not really charged, we simply count the number of atoms. All right? So in this case, if we wanted to, we'll skip that one for a second, but if this case we wanted to say there's a nitrogen with 2 oxygen, well, what's a good prefix for 2? Di. All right? And so we're going to have, this is nitrogen, what? Dioxide. And this would be, careful, dinitrogen, either oxide or, what's 1? Monoxide. Monooxide, monoxide. Okay? This one?
Dinitrogen pentoxide.
Dinitrogen pentoxide. Okay? So those are the simple 3 naming systems. So either if it's in one tower or the other, one with this, one over here, simple name, just give the name, give the other name, make it an ide. If it's the valley, you're going to identify the charge. All right, iron 3 chlorine, iron 2 chloride. You still have to figure out the formula, but is everybody okay with figuring out the formulas? You know, you just go, this is +3, this is +2, so there's 2 of those, 3 of those.
Yeah.
All right, good. All right, so please don't do the silly crisscross method. Please think about it this way. If it's iron 3 oxide, all right, how many of these am I going to need? What's the smallest thing that 3 and 2 goes into?
6.
6. So how many of these do I need to get to +6?
2.
2 of them. And how many of these do I need?
3.
3 of them. Simple, yes? All right. So another silly little memory hook is that we're going to identify if it's through the valley, we're going to use the charge, right? And if it's 2 of the things in the tower, it's going to be a die and try and so forth. So one of my students a few years back said, Mr. Ribbian, I got it. You charge through the valley and you try not to die in the tower. Okay. Does that make sense? Was that helpful? Yes? No, not at all.